Geometry, Chapter 3, Lesson 5, I believe. Yes. Chapter 3, Lesson 5, we're looking at polygons, and we have a theorem from the last lesson where we were looking at triangles, and we know that all the angles inside the triangle add up to 180 degrees. Well, how did they come up with that number, and how do we know that? And what happens if we're not looking at a triangle, but we're looking at, say, a quadrilateral, or a pentagon, or a heptagon, or maybe even a dodecagon? What do all the angles inside add up to in that case? And so I'm going to do this little activities for you, record it, and we can, by looking at this, maybe come to a conclusion or make a conjecture about what these angles add up to, or at least maybe have a way to determine it. So we're going to make this little chart here, and we're going to sketch polygons with 4, 5, 6, 7, and 8 sides, and then we're going to divide the polygons into triangles by drawing diagonals from just one of the vertices, and then we're going to multiply that number by 180 because we know that all the angles in a triangle add up to 180. And let's see if we can't figure out a pattern. So here we have the 5 figures we're going to do. So let's do the square first. So how many sides are there to a square? Well, there's 4 sides, so we're going to write that down here. 4 sides to a square. Now, if we draw diagonals going from one vertice to any other that's non-consecutive, remember that makes a diagonal, how many triangles here are formed? Well, there's a triangle here. Well, let me do this a darker color. So a triangle here and a triangle here. So we have 2 triangles formed. And we know that the angles inside a triangle, this one plus this one plus this one, all add up to 180. Well, I have 2 triangles, this one, and this one. So if I have 2 triangles, 180 each, then the total number of all of the angles inside this polygon then are going to be equal to 360 degrees. So a triangle, you remember, was 180 degrees, 4 sides is 360. So let's take a look at a pentagon then and see how that happens. So here we have 5 sides to begin with. Now if we divide our polygon by going from one vertices and drawing all the possible diagonals, so I can go from there to there and there to there, those are the only diagonals. Now how many triangles do I have? 1, 2, 3. So I have 3 triangles, and you know what, I'm going to have to erase this so I have more room for those other ones, but just kind of keep that in mind. So I have 5 sides in this one. I end up with 3 triangles in the side. So if I multiply 3 times 180, I get 540. Alright, so let's do the next figure then. Here is a hexagon that has 6 sides. So if we divide that, going from one vertices using the diagonal, here's one, oops, let's see, it's another diagonal, and then another diagonal. Alright, then how many triangles do we have here? Well, here's a triangle, here's a triangle, here's a triangle, here's a triangle. So there'd be 4, and I know there's 180 in each triangle, so if I multiply 180 by 4, I'm going to get 620. No, that's not right. What am I going to get? I'm terrible at my math here. 480 and 320, that's going to be 720. So what that's going to be. Okay, so let's do a 7-sided figure then. So here's our 7-sided figure. So we have 7 sides. And if we break this up, so here's one diagonal, go from there to there. There's another one, and another one. So how many triangles do we add up when we do that? So there's 1, 2, 3, 4, 5 triangles in this one. So 5 times 180 then would give me, let's see, oh, that's a big number, 720, 820 would be 900, right? 900. Okay, so let's do the 8-sided figures. So now if I have 8 sides and I draw the diagonals, okay, let's choose this one here. So there's one diagonal, go from here to here, 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 here. So then how many triangles do we have? 1, 2, 3, 4, 5, 6. So there's 6 triangles. So what does that add up to? So that's going to be 1,080. Okay, so if we do this, then what do we notice then about the number of sides, how many sides there are, and then when we draw the diagonals, how many triangles we have. Okay, well here we have 4 sides and then 2, 5's 3, 6 goes to 4, 7 goes to 5. So actually, if we take the number of sides, let's call it n, any side that we want, this will be our conjecture. It doesn't matter how many sides we have. If we take that number and subtract 2, that gives us how many triangles are inside. 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5, 8 minus 6 is 8 minus 2 is 6. So it seems to me that if you take the number of sides and you subtract 2, that gives you how many triangles there are. And then if you take that number, whatever it is, and multiply it by 180, that gives us the sum of all the interior angles. Okay? So that's what this exercise seems to show us, is that if you know the number of sides in a polygon, you subtract 2, that gives you how many triangles there are, and we know there's 180 degrees in a triangle, so if we multiply that number by 180, that gives us all of the angles inside the polygon added together. So that would be, let me do some erasing here. So it would seem if we took the number of sides and subtracted 2, and then multiply that number by the number of triangles that are formed, or angles in a triangle, 180, that will give us all of the interior angles of a polygon added together. So if I were to add this angle plus this angle plus this angle plus this angle, that should add up to 360. Or in a pentagon, if I added this angle plus this angle plus this angle, that would add up to 540. Or if I took one angle here plus this angle plus this angle plus this angle plus this angle plus this angle, that would equal 720. And we already know that a triangle, 1, 2, 3, always adds up to 180. And that actually fits this too. If you took the number of sides 3 minus how many triangles we formed, minus 2 would be 1 times 180 gives us 180. So this is the triangle, or I'm sorry, the polygon angle sum theorem then. What we did was just give a, oh, Chewan, Carlota, and a few people wanted to say hi to you. If you know the number of sides in a polygon, all you need to do is take the number of sides, subtract 2 from it, multiply it by 180, and that will tell you what all the angles inside a triangle, inside any polygon add up to. And again, we're all about relationships. So knowing this little equation, and this really is simply just an equation, n minus 2 times 180 equals the sum of all angles. Make that interior angles, it's important. Then it doesn't matter whether you know the number of sides, you can figure out how many angles or what the measures all add up to. Or if you know what the measures all add up to, you can just put the number in on this side, solve the equation for n, and figure out how many sides there are. So that's the polygon angle sum theorem, and that little exercise kind of gives you an idea of where it comes from.